Welcome back, everyone. This is Legit Lee here, back with another update of my Filastruder. Now, I went ahead and wired up. I just got my PID in like a day ago or 2 days ago. I think it was yesterday. I can't really remember. But as you can see, I have my PID is set at 60 degrees Celsius just to test it out, and once it goes below that 60 degrees right there, the top one will go below 60 degrees because it's off at the moment because it's set at 60. That red light, there it goes, will come on to keep the heat around 60 degrees. So, and it's wired up to the back. I'll show the wiring in just a second. But you can see in the back there, the SSR, solid state relay, is going in from here, from the PID controller, comes out to mains voltage. So basically, say you had like a cut in your power cord, so like one of these wires was cut, then you attached, so say like these two were supposed to be together, but I cut them, and then I attached one end to the outlet that goes to the heater over here, and then the other one will go on the other side, will go to the power outlet, or to the mains voltage is what they would call it. So you only need to cut one wire, or put one wire. Basically this just connects back there, connects the bridge of those cut wires back to one wire. And that's what turns my heater on over here. So one wire goes straight to the plug of like an source, basically a source plug, and then the other wire is cut in half. So one of that half wire goes there, and the other half goes on the other side of the terminals. And then I had this thermocoupler here that tells the heat. So from right here, the heat from right here to right here is 60 degrees Celsius. And I mean, yeah, it's pretty warm. You touch it, it's warm. So I was just testing it out. I can set this to 240, which is melting point for ABS plastic. And then so I could set that heater for that. So pretty much this is kind of done. The only thing I have to do is cut a little gash out the top here and add a hopper, that's what it's called, where you put all the pellets or your chopped up pieces of plastic that falls into here, and with this actually spinning around, it'll push all the way down to the heating point, melt the plastic, and then create a big plastic bubble lump type. Like it just will fill up, kind of like filling up water, just like this. And then so the only way that the plastic will come out is through that little hole at the front right here. So basically it'll just fall out once it has enough force coming from the screw drive. So basically it'll push all the way down, melts at the tipping point while it's still being pushed down, because it's not going to come back this way. The drill bit is going to keep spinning and pushing the filament all the way out the tip, just like a filled up cap of water, and it's just being squeezed out. So that's basically how this is working. So now that I got the heater set up, and right now I'm 3D printing me some gears. I'm gonna show you one over here. I got some gears that I'm 3D printing, so that way I could make an actual geared motor for more torque for this motor right here that I showed you guys earlier. And you can see that I already put one on there. I got that one on there pretty good. I had to tap it down, like smack it against the floor to make it fit on there good, but it's on there, so I don't have to worry about that. I designed that gear myself. I mean, I haven't designed the whole entire gear. I just like updated a previous design from somebody else, so that way it will fit on my shaft here, because it's a 10mm shaft, and it should work just fine. And then with that gear, and then this, a few of these other gears, it'll make enough torque to spin this shaft which will then spin the drill bit, and then it'll be able to produce my filament. So all these wraps that I've been doing, especially right now because I'm still 3D printing, these little wraps right here basically just go in the top here, all chopped up. I'll chop it up with like a pair of scissors or something like that. Put it in here, it'll flow all the way down through the shaft and come out to be just like some kind of string that'll come out the tip right here like that. So I hope you guys like this video. This is just another update. It's my update number 2. Yeah, this is update number 2 on my 3D printer's filament extruder. And you guys are gonna love, after I get this, I already have plans of my upgraded version of this. You guys will love that one because I was doing a lot of research, and I like this setup, don't get me wrong, but to me this is a crude setup. Now don't, I understand you guys probably would, say something like, oh no, that's the way it should be. No, to me it's a crude setup because there's a better way of actually making this whole system, and that's with using Arduino and PID heater bands. So you could program the Arduino to heat one of these up. Now I feel like this is so nostalgic because I feel like I said something like this before, like years ago, and I was telling somebody about something like this. But basically you could heat up this heater band here, this heater cartridge, that's what it's called. These are for 3D printers. They are used for the Bowden here. You can see right there in that block. Let me just show you. See that little piece right there? They slide right into that front part, and that's what makes your heat up that. Basically, it heats up that block right there, melts down the plastic, and it comes out of that little brass or golden hole right there, and that's where that heater comes from. So like I want to use like 4 of these inside of a cylinder at the tip right here. Ooh, that is kind of warm. Staying pretty warm, even right here. Okay, so basically I'm gonna have a big thick cylinder that goes on the shaft of here, and it's gonna be made out of aluminum, and I'm gonna drill some holes out to slide it into that shaft that I'm gonna have made. So basically, instead of having this heater band, the whole pipe itself will be the heater band itself. So I don't actually have to worry about that. So it'll be more precise heat also, because with me, using Arduino, I mean, we use that for pretty much all the 3D printing motherboards are using Arduino coding somewhere in it for the most part. And basically it's more precise heating, so you don't actually ever have to worry about overheat or underheat. For the most part, it's this, like the Arduino version of that is so much more precise and better for you, because not only that, but you could set it up for a time of day if you want. You could set the Arduino to have like a time that you normally start wanting to have your extruder turn on or something like that. So like you could say leave the Arduino plugged up overnight, and then at 5 o'clock in the morning you can have it set at a certain time. It'll automatically come on, start heating up, and then wait for you to come into the room or whatever. You could press a button, like, get it already preset for heat, and then all you gotta do is just start throwing in your plastic, start the machine up, and then it's already preheated, so it'll just instantly start melting everything. So that's what I'm trying to say, is this way is way more precise because it gives you way more options for customization. So that's one of the things that I want to do, and that's coming really soon also. So I'm not gonna tell you guys, hey, I'm gonna do this, and a few months later or something like that. It doesn't have, like, I have to wait so long. Pretty much within the next, I want to say, give me like 1 month from now, I would say, and it should be fully operational and working. I may just have 2. I may just keep this one like this, put like a you know, drill a little hole somewhere to put this heater, like, you know, thermistor inside of here somewhere. And then so basically I'll put this in here somewhere and just keep this whole system by itself, and then start me another one, because I already have most of the heater cartridges. I know where to get. I could get a smaller pipe. Really, in the future, I would love to be able to make one that's portable. So basically, like, if you went to a friend's house and, you know, you guys are thinking about 3D print, I want to be able to have a 3D printer that's portable also, like a small 3D printer and a small filament extruder. So, like, you could just, you know, go to a friend's house if you wanted to, or like your mom if you're living on, like, on your own, or, you know, if you're in college or something like that. Basically, small enough so it's portable that, you know, okay, you're over there, you're like, hey, let's get something to drink. There you go, you got a fresh bottle of water now. You drunk all the water, you're at a football game, whatever. You just plug it into any main power source, which, you know, if you're at college or home or whatever, there's always going to be a power outlet somewhere that somebody can use for just, you know, about an hour or so. And basically, you know, you got done drinking your water, you chopped it all up, you put it inside the filament extruder, extruded it into filament, and then you put it inside a small carry-on printer, and then bam, you had whatever you're thinking about printing. And I mean, you could set that up with most tablets nowadays for your 3D printing. So like, if you get like a Windows 10, you know, little tablet thing, you'll be able to actually use the coding and design you something right there on the spot. Export it to STL file, and then you know, use Kira or whatever slicing program you have, and then turn it into a G code and start printing out. You know, instead of having to worry about being home all the time. I mean, I'm gonna get set up for a lot of different stuff. I mean, I'm really going pretty much 3D crazy. I do have a Raspberry Pi, like I mentioned in the earlier video, and here it is. I can use this for Octoprint. Once I gotta call Netgear, because that's the router that I have. And basically, with Netgear or any router, you have to get your routers basically the code, their router's number. I can't remember the name of it. I'm sorry. There's a name for what I'm trying to say, and it's IP address. There you go. I'm sorry. The router's IP address, so you can log into the router's IP address, set up your own wireless network, basically 3D printing, and you'll be able to monitor, you know, your 3D prints while you're not home or whatever. So, I mean, there's plenty of videos on how people are using that. So, I mean, that's how I found it. But besides all that, guys, I hope you liked the video. Please like, subscribe, and like I said, this is set at 60 degrees Celsius, and whenever it does go below that 60 mark, when it starts to cool, it'll just turn back on. You'll see the little red light come on, indicating that it turned on to keep it at that set temperature. See, it just came on and shut off, and that's why it's keeping this over here relatively pretty warm. Like, if I hold on to this, it'll probably burn me, so I'm not going to do that. But I could touch it right now. I just barely tap it, and I could feel that it's pretty warm. So, but yeah, this is all set up pretty well. Like I said, all I gotta do is just cut a hole out of the top here, 3D print me something like this, but reverse, that will allow me to drop in pieces of plastic into it while it's spinning and pushing it all down, and then bam, I'll have more plastic, recycled waste, whatever. I'm going green for everybody. I have a lot of plans in the future about 3D printing, so I hope you guys do subscribe, and you guys are going to want to see what I've been thinking about and what I've been coming up with. I have a lot of ideas in mind. I don't really draw them up on sketches or anything because of the fact I pretty much store all my ideas in the top of my head. Like, I've had plenty of ideas about plenty of different stuff, and I'm able to actually remember pretty much all of them. And even the ones that I did forget, I forgot on purpose because I didn't really want to do it, and I was just, you know, one of those things that you just think about doing, but you're not really sure if you want it to or not, so you like did some research on it and found out it wasn't for you. So but for like the majority, I'll say 99% of the time, if I have an idea in my mind, I'm gonna make it into reality. I always am dead set on making my dreams and my creations come into reality, because I know they sound crazy as hell, and pretty much like I'm always thinking and watching something that's like cartoon related, anime or whatever. Like I'm always doing something, and I just would love to be in their world so much that, so since I can't be in their world, I'll bring their world into our world. And that's pretty much where I started off at. So you guys, please go ahead and like and subscribe, because you're not gonna want to miss out what I got in store for you. You guys have a great day, and this is Legit Lee signing out.